after 10 minutes, sure, why not? You're just going to miss important things in class. But yes, you can go. Ashante, yes. Helen, yes. Valency, yes. Kennelly, yes. Jordan, Veronica, Demare, Tanisha, Asper. Yes. Emily. Here's the code you need, ladies and gentlemen, to get logged into the Pear Deck. Please do so. Okay, questions before we get going today, ladies and gentlemen? You sure? Yes. Okay. And I do get notice when you turn them in. Even if you turn them in late, I do get notice. So.
Is that something that you did? Because I know one of my other teachers doesn't get like notifications.
Well, you can. There is a way you can set notifications too. If you are on the main page of your class, okay. So your main page, now this is the home page for this class. You have this option as well, view course notifications. Now I have mine clicked and it sends me a daily update of when you turn things in. If you turn in late assignments and things like that. But I also get this part down here, things to do, grade graphing to find density lab. You guys don't get this, but you have probably a to-do list of some kind here. And it tells me, okay, one person has turned that in, 9 people have turned this in, 41 have turned this in. So then that's a reminder for me to go in and grade those things. But I do appreciate you letting me know, but I do get notification. Now, here's what I would tell you, ladies and gentlemen. If you turn something in late and then you don't see it appear in the grade book, give me a day or two to get it graded, please. But if you don't see it appear in the grade book, then you need to let me know because maybe I forgot, maybe I didn't do something right, things like that. Okay? So thank you for letting me know. But like I said, I do get emails and notifications like when you turn things in. So just so you're aware of it. So, okay. Questions?
Does it have to be important?
Well, it should pertain to the class right now, but I guess we're a little bit freelancing. So go.
What was your natural hair color?
This is my natural hair color.
You were always stressed?
Stressed is not a color.
But gray is.
Okay, so this is my natural hair color now. When I was a young kid, I was blonde. Then in my middle years, I was darker haired, and now I'm this. And don't ask me why I've gone through all those hair color changes because I've never dyed my hair once. My brother does, but I don't. Anyway, ladies and gentlemen, questions?
What color does your brother dye his hair?
He must dye it blonde because his hair is blonde, but his beard is gray. So that's the only thing I can think of is that he has to dye his hair. Yes.
Would you dye your hair?
Would I dye my hair? Not for $1 million.
You
So-
would.
If you actually, if you didn't have a choice, like what color?
Well, I always have a choice.
Like if you didn't, like what color?
I always have a choice.
Bro, you would never dye your hair for
Nope.
$3.
Nope.
$3.
Nope.
Really?
I wouldn't do it.
You would? Wow.
I just
Not
wouldn't do it.
even like a dirty blonde, not even like a brown.
No.
Would you dye your hair like red?
No.
What if we just dyed it?
Why are we discussing this when you're getting the same answer from me?
Not even gray.
I don't have to even dye it gray. It just naturally goes that way.
Right. So that's the difference if you dye it gray.
Then I guess it's already dyed that way. Okay, good.
But if you dye it gray, then you can excuse yourself by saying you just dye it that color.
Also, somebody.
I don't care what color my hair is. Okay, you're gonna learn a couple things about me. This haircut is 2 seconds in the morning. You get out of the shower, you do this, I'm ready to go. Okay? Don't have to do anything else. Boom, ready to go. Every once in a while I do one of these and I'm fine. Okay?
At least you have a full head of hair.
It's true. I always say it's better gray than gone. So
You like your hair gray?
I like it better than being gone. Okay, here we go, ladies and gentlemen. Today, we're going to talk about and review that classifying matter activity. I will talk to you about how I graded it. We're going to take the Unit 2 Quiz 1, and then I'm going to review atomic structure real quick, and we're going to try to get through all of that today. Today, you will be able to understand the parts of an atom and terminology that describe atoms. Just a reminder, ladies and gentlemen, we are probably about halfway through this unit, so that means that if you want to do a retake, you don't have a whole lot of time left because it has to be done before the next unit test is given. And it's not a good idea to be studying for the Unit 1 retake the night before you're studying before the Unit 2 test. So you may want to get it done, ladies and gentlemen. Okay, good, excellent, wonderful. Take a look. Yes.
When is our next test?
I don't know yet. I haven't figured that out. But it's coming in probably a couple weeks, maybe less. Okay? This image represents which of the following? Okay, now let's try to clarify this for you. When we classify matter, we break it into 2 categories. What are they?
Pure substance and mixture.
Pure substance and a mixture. Pure substance, when you are looking at it, there will only be one type of thing there. There may be multiple things combined together, but everything will look like those multiple things combined together. Everything will look exactly the same. That would be a pure substance. Everything that is in your container, everything, picture, or atom that is in your picture will look exactly the same. That makes it a pure substance. Even if they're combined together, everything would look like those same things combined together. And then there is a mixture. And a mixture is when you have multiple different things together in the same area. Now, if we determine that it is a pure substance, now we ask ourselves, is that pure substance made of only one kind of thing? If it is, that is an element. If there are multiple things kind of hooked together or connected, that becomes a compound. If we go to the mixture side, first of all, there have to be different things in the container, in the sample, something like that. And then those different things need to either be evenly spread out or have a pattern to them, or they need to be unevenly spread out and have no pattern to them. So when you look at the picture up there, how many different things do you see? 2. We see the green sears, we see the purple sears, correct? That makes this a what? Substance or mixture? Mixture. Now we got to figure out what kind of mixture it is. To be a homogeneous mixture, things would be kind of evenly spread out, or there would be a pattern to it. Is there any pattern to this? So what is this? This is a heterogeneous mixture. Very good questions. Okay, picture 2. Take a look at it. What do you notice? They're all exactly the same, meaning substance or mixture. Substance. Now, all the things that are the same, are they one thing or are they multiple things kind of hooked or combined together? So what is this? This is an element. Very good. Okay, so now we've got a container of salt water. So what goes into salt water? And good, thank you. I'm trying not to be, but yes, salt and water. Now, bless you. Stop it.
Someone kept doing that
That's
first hour.
insubordination when you don't listen to a teacher.
First hour.
Good now.
Yes.
Okay, so what is salt?
So
It's a compound.
It's an element.
Salt would be a compound. Show me where salt is on the periodic table.
I don't think of the.
It's sodium.
Okay. Yeah, but there's not salt up there. They're makings for salt, but not salt. So it would have to be listed on the periodic table to be an element. Okay?
I would have forgot that Na wasn't actually table salt.
Okay, correct. Good. NaCl is table salt. Na, an element, Cl, an element, come together, make salt. Yes. What?
What's the big one?
Where's the big one?
The big periodic table.
It's
I feel like I'm being like.
gone.
I feel like you're gonna be like, oh, it was never there. What are you talking about? Like, it's-
Why would I do that?
you don't know.
I was asked to take it down.
Oh,
Why?
fire marshal was
The
here.
fire marshal was here
Could
yesterday.
you at least put it somewhere else?
Put it back.
How?
No.
Is it a wrist?
Why not?
It's on the ceiling.
Correct. But I had little hooks that held it up that pushed the tile up a little bit. So technically that's a fire hazard.
With little hooks in there.
No. Those hooks are on the metal frame
Why don't you just work the hooks instead of taking it out?
because those hooks aren't strong enough to hold up that periodic table. And I didn't think Astro wanted to wear the periodic table on his head halfway through a class. I tried using very strong magnets and they weren't strong enough. I don't believe that the command hooks like I have there are going to be strong enough to hold that period. What's that?
10,000.
It's pretty heavy. That periodic table, I mean, it's not heavy, but for being on a ceiling and being about 6 feet above your head, I really didn't want it crashing down and landing on somebody. That one, at least if it crashes down and lands on somebody, I doubt it'll kill them too bad. It may just hospitalize them for a while. So, yes, Ava.
Can I have a charger, please? Or is there any up there?
Well, mine didn't work. So
Oh.
I mean, it does work.
Well, why are you stealing my charger when you got a goddamn cord that runs into the wall?
The thing is, I plugged it in and it said it wouldn't work because it had too low battery.
It always says that. Just plug it in and let it go. I've had those chargers for 3 years now, and they always work. You're gonna ask me if you can go to the bathroom, right?
No,
What are you gonna
ask you? Why didn't you stick it up there with tape?
That
Oh my god.
Yeah.
because I think that's stronger than tape. The old one, you mean?
Yeah.
They won't let me tape to the. The only thing I can do is I can attach it to the metal framework. That's it. And if I had put tape on it and gone over the framework, it would have been pushing up the tiles, and they couldn't tell me I had to take it down. Right? 20-some years, the fire marshal said I had to take it down.
Why?
Cause it. We just had this discussion, Asia.
Sorry, I'm looking over on my computer.
Because technically, it's a fire hazard. They say.
Bye.
So again, I'm not disagreeing with you, but I'm also not trying to get Miss Lip, our new
So
principal,
that's
in
not
trouble.
fire hazard?
No, because it's not pushing the ceiling tiles up.
Is the fire marshal ever written anything?
Yeah.
We've had it for years.
Yeah, and different guys have said different things, and then this guy said take it down, and so I took it down.
That is-
So, all right. So again, salt is a compound. What is water? Compound. Compound. When we put the two together, does the water change the salt and the salt change the water chemically? No, it does not. All they do is they mix together, right? Okay. When they mix together, how do they mix together? Evenly or unevenly? Evenly. That's why you don't see the salt sitting at the bottom. It's mixed throughout the whole water. You take a drink of the water, you're always going to get salt water. So again, salt and water together make it a mixture or substance. Mixture. Evenly spread out makes it homogeneous. Very good. Homogeneous. Okay? All right. Two or more substances chemically combined. What's that the definition of? That is the definition of a compound. Two or more substances physically combined. And I stop there. Physically combined means it must be a what? Mixture. And then the end evenly distributed means it has to be a homogeneous mixture. So the first part, physically combined, says mixture. The last part, evenly distributed, means that it is homogeneous. Questions? Wonderful. So yesterday, ladies and gentlemen, I gave you an activity to do at the end of class, and we gave you about 20 minutes to do it. Now, I did collect them, I did grade them, and I did put them in the grade book, and I gave you one of 3 grades for doing it. Grade number 1, if you filled everything in, all the yellow boxes that I asked, you got a 10 out of 10. I didn't even look to see if you were right or wrong. I just gave you 10 out of 10 for doing it. If you left some boxes blank, you got a 6 out of 10 because it was incomplete. And if you didn't turn it in, you got a 0 out of 10 because I can't grade something that is not turned in. So if you did not turn it in yesterday, my suggestion would be to turn it in today so that at least you get some credit for it, because that's a lot better than a 0. Here is the first sample. So when you look inside this container, do all of the things inside this container look alike, or are they different, or do they look different from each other? They look alike, meaning pure substance or mixture? Pure substance. Now the next question is, if I pick one of them up, is there one type of thing here or 2? And they are what? Connected. Trying to show you that this is a compound. Trying to show you that these things are connected into one thing. That is what a compound is. This could be water, ladies and gentlemen. 2 hydrogens, 1 oxygen. Okay? But everything in here looks exactly the same. Pure substance. 2 or more things together make it a compound. Questions? Wonderful. Let's go to number 2 here. This is number 2, ladies and gentlemen. One thing or multiple things in there? Multiple. Now, I've had people argue with me, and they've made a good argument. Well, Mr. Brandon, every one of those things is a nut. Okay, fine. So they put down a element because they're all nuts. Okay, but technically they're different kinds of nuts. Okay, so now that becomes a mixture. You've got 3 different ones in here. We have a mixture of things in here. Homogeneous or heterogeneous? Hetero, because there's not a pattern here. They're not evenly spread out. That is very difficult to demonstrate, but I tried in a couple of them. Okay, so now we go to the next one, ladies and gentlemen. Boom, right here. Again, one type of thing in there or multiple? 1, which means this is a pure substance. Now, pure substance, element or compound. Is there one thing here, or are there multiple things together to make that one thing? There's only one thing here, so yes, you are correct. That is going to be an element. Going to be an element. Now we go to number 4 here. Oh, by the way, ladies and gentlemen, I am really, really, really looking forward to giving you guys things like concentrated hydrochloric acid. I'm really looking forward to giving you instructions like, don't mix these 2 things together. Because I gave you one instruction on 2 stations, which was please don't touch the tray or the things inside of it. And yet every hour I had to go back and reorganize both tray 4 and tray 7. Because apparently do not touch means I've got to touch it and move things around. Now, I am upset about this, not because you did it, but because I don't know if I can trust you when we get to a lab where when I tell you not to do something, you won't do it even though it may hurt you. Now, I would hope you will listen to me then, because we are going to work with acids that if you get them on your skin, they will burn and eat away at your skin. We are going to work with acids that if you get them in your eyes, there's a good chance you could go blind. And I'm telling you this not to scare you. I'm telling you this because I want to do labs with you that we can do more than these kiddie labs you did when you were a 9th grader. And to do that, I have to trust that you're not going to take 2 things that I tell you not to mix together and mix them together because, oh, I just want to see what happens. Or, oh, I really don't care what he said. So while your safety may not be important to you, it is to me because I want to keep my job. Okay? And people who do foolish things often sue people who didn't do foolish things because you didn't tell me exactly not to do the foolish thing that I did. And I'd rather that not happen to me. So please, when I ask you not to do something, there is a very good reason for it. And the reason I asked you not to touch this one is because I was trying to set something up for everybody else to see. And if you move things around, when they get to the station, they're not seeing what they were supposed to. What are we seeing in here, ladies and gentlemen? Are we seeing one thing or many things? Many things, which means we're seeing a what? A mixture. And I'm sorry we're not seeing it very clearly because my hover cam is not focusing very well.
Mr. Brad,
Let's see if I can do that and get it to focus. Yes.
doesn't that work with everything except collateral? Like if someone does something stupid and someone else gets caught in the crossfire, they didn't do anything.
So I don't understand what
That
you
would
mean by.
still give you trouble. You're trying to avoid it, but it doesn't fix it.
Well, there's a difference between being collateral damage and being dumb. If you do dumb things, things are going to happen at some point in time. Okay? I have never fallen off a balance beam because I don't walk on one. But if you walk on something often enough, you're probably going to fall off at one time. If you mess around in the lab, you're probably going to hurt someone or yourself one time. I'd just rather it not be in my class. So when you look at this, ladies and gentlemen, is there a pattern here? I tried as best as I could to establish one. The combo, blue, yellow. The combo, blue, yellow. The combo, blue, yellow. So that was supposed to represent a homogeneous mixture. Yes, thank you. Homogeneous mixture. Okay, now this, one thing or a mixture? Definitely a mixture. And it is amazing what you can do with all that crap that your father collected over the years and put in a coffee can and left in his garage. Okay? And then the sad part is sometimes the son does the same darn thing, and then you get something like this. Okay? This is a mixture. Is it evenly spread out?
No.
So what kind of mixture? Heterogeneous. Good. Good. All right, that was 5. Let's go to 6. One type of thing or many types of things? One. And it's an element Y. Well, there's only one thing and it's made up of just one thing. It's not multiple things together. That makes it an element. Very good. Okay. Here we go. Number 7. Bless you. Okay. Stop it. Enough already. You've got our attention. Okay.
You okay?
Yes.
Mixture or pure substance? 2 or more things here, right? Makes it a mixture. Homogeneous, heterogeneous. Why? Trying to establish a pattern here. Okay, this one got some people. And again, I think hopefully now we have a little better understanding of it than we did yesterday when we were doing it. When you look at this, is there one type of thing here or many? One. One type of thing. Meaning each of these things is exactly the same. Now, they're made up of different things. But if you take one of these out, does it look like the other ones that are there and left in it? Yes. So this is one type of matter, or trying to represent it. So that makes it a pure substance. But is this an element or a compound? A compound because it is made up of 3 different things: the bolt, the washers, and the nut. Okay? So that is what I was going for here, ladies and gentlemen. Each of these is identical to each other, but there's more than one thing there. Questions? Okay. So now it shouldn't be a problem. Now you should be able to get your activity turned in. Wonderful, wonderful, wonderful. Thank you for doing so. All right. Get in your computers, ladies and gentlemen. Go to your EISNs and get to slide number 61. Okay. So everything, whether it is those elements, whether it is compounds, whether it is homogeneous mixtures, or whether it is heterogeneous mixtures, everything in the world is made up of atoms. There's a list of the atoms. There's a smaller list of the atoms. There's a list over there. There's a list over there. We still got lots of lists of atoms. But what makes atoms different from each other? What makes carbon different from nitrogen? What makes oxygen different from gold? What makes silver different from titanium, at least in a structural level.
The amount of protons, neutrons, and electrons.
Good. We call those things the subatomic particles. The particles that they are made of. And you were absolutely correct, Alan. There are protons, there are neutrons, and there are electrons. They make up atoms. They are what we call subatomic particles. And what makes them different from each other is their charge, their location, and their mass. Now, again, some of you were lucky enough to have me as your chemistry portion of physical science teacher. And I have taught you this. And I'm reviewing this not because I don't think you know it, because if you had me as a teacher, I'm sure you remember everything I've ever taught you. I was waiting for a laugh. No, nothing. Okay. But because as part of the class, I think I should at least go over it with you, even though you should already know it. So, ladies and gentlemen, here we go. Actually, I see some people typing still, so I will calmly wait a moment. At the end of the hour. Maybe Monday. How's that? Nah, we'll do it today. You're all here. I hate to ruin your weekend by not giving you the quiz. Then you'd be worried about it all weekend and stuff. Yes. How long is it? 14 inches.
Okay, you don't finish it, or you just.
Oh,
Is it short then?
what?
Is it like short, only a couple questions?
There's only like 12, 13, 15, 25, 30 questions, something like that.
So,
No, 70 would be an unusually large amount. Asia, can I get
is there like any definitions you did like get on the quiz or like the chemistry definition or anything?
No, I didn't give you the definition of chemistry on this one. Okay? But you should know what kinetic energy, potential energy is. You should know what heat and temperature are. You should know what KMT is. All that stuff that we talked about yesterday. Okay? Good. Here we go, ladies and gentlemen. So this is what this table looks like. Take a minute, copy it down. It's not in your slides for you, so you got to copy it down. So I'll give you a couple minutes to type. Let's find out who the slowest typer is. And since I'm done, I can't wait.
There's the
You're lucky, Helen. Those are free today. On Monday, they're a quarter.
Per use.
Hmm?
Per use.
Per sheet.
Oh,
Are those ones the cheap ones?
No, those are the better ones. Those are 35 cents. Just because it's a smaller box doesn't mean it isn't better. Uh-oh, which one of you is in trouble? Tell me now. Tell me now. Mr. Brand. Yes. Okay, we'll do. Thank you. Bye. Helen, they found out about you stealing the tissues. They want to see you in the attendance office right now. You are coming back, they said, so you can leave your stuff if you'd like. They're just going to fine you and then send you back for stealing tissues.
Okay.
Mr. Brand,
Yes.
I don't know if she'll come back this second.
Well, we'll have to see when she gets back. Okay, are we ready, ladies and gentlemen? Okay. So the difference between protons, neutrons, and electrons fall into three things. They are different in charge. Now, in terms of charge, there are only two types of charges you can have, but you do not have to have a charge. So if you are charged, there's two charges. If you're not charged, that's fine. The two charges are positive and negative. Now, tell me what two things we know about positive and negative charges.
They repel each other.
No, they don't. You're close though.
Attract each other.
They attract each
Oh,
other.
the opposites attract.
Obviously, you've never watched those silly Hallmark movies that my wife loves so much, where the opposite people just attract to each other. Anyway, ladies and gentlemen, opposites do attract. Opposites also do what to each other?
Neutralize each other.
They cancel each other's charge out. So a positive charge and a negative charge will cancel each other out. Okay? Now, protons, neutrons, they're located in the center of the atom, the nucleus. The electrons are around it in the electron cloud, and the electrons are actually a long way away from the nucleus. Most of the space of an atom is empty because it's created by the fact that the electrons are far away from the center. Kind of like our universe, ladies and gentlemen, or our galaxy. The planets in it are very far away from the sun. Most of our galaxy is empty space. Mass. Protons and neutrons have a mass of 1 AMU, and an electron has a mass of 1/2000th of an AMU. So what that really means is that electrons really we can't say they have no mass, but compared to the rest of the atom, we could say they really don't matter in terms of mass. Would kind of like be getting up in the morning, stepping on the scale and realizing you need to lose some weight. So you walk over to the sink, you pull 3 hairs out of your head, you throw them in the sink, and you go back on the scale. Did you lose weight? You sure did. Is it going to show up on the scale? No, it isn't. Okay? All right. By the way, AMU, ladies and gentlemen, stands for atomic mass unit. It is a really, really, really small amount. Really, really, really small amount. 1.67 times 10 to the negative 27th kilograms. That is this number right here. Very, very, very small number. But that's okay because it's balanced off by a very, 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 very big number I've already given you, which is what? My last class said pi. 3.14. Yeah, that's a big number. Yeah, no.
Do we have to know that for?
No, you don't. You do not. But does anybody know the really big number I'm talking about? There goes that whole theory, you don't forget something when I taught it to you.
Mole.
What's the mole?
Amount of substance.
Number.
6.02 times 10 to the
Oh,
23rd.
that thing.
That's the big number we're talking about, ladies and gentlemen. That's the big number we're talking about. Okay, when you look at a periodic table, ladies and gentlemen, there is a certain amount of information that almost every periodic table has. You will for sure find 3 out of these 4 things on a periodic table. The one you will not always find is the name, although the periodic tables I have up in the room, except for the one from 1930, do include the names on them. Okay? The number on the top, and it isn't always on top, but the whole number, the small whole number in the box is the what we call atomic number. That is actually the number of protons, ladies and gentlemen, and that is always a whole number, and that is how the periodic table is arranged. Okay, in a map of the United States, what do they do with Alaska and Hawaii?
Put it in the corner.
They put it in the corner. Why?
Because they're not actually part of the mainland.
Okay, but they're part of the United States. Why did they put them in a corner? Were they bad? Did they misbehave?
To show that we still have.
Okay, and also because if we did it to scale, Alaska, well, not Alaska, but Hawaii is a long way away, right? Long way away. Which would mean that if we did it to scale, the whole United States on a photo or on a piece of paper would become smaller to account for that. Well, these elements down here are kind of like Alaska and Hawaii, ladies and gentlemen. They actually belong right here and right here. But we cannot put them there because then the periodic table would get too wide. It would get too wide, be too hard to read because everything would get smaller. So we take them out, we put them down here. But here is 88, here is 104, here's 89 through 103. Here's 56, here's 72, here's 57 through 71. So that's just what we do with them. We put them at the bottom, ladies and gentlemen. Now, take a look at the board over here, ladies and gentlemen. By the way, for those of you who didn't know, this is where I put your assignments and your reminders and things like that. And what do you notice about my beautiful handwriting, ladies and gentlemen? What? Yeah, because it's beautiful. I write really well. But what do you notice about it?
It's in all caps because you don't like writing short.
I write always in capital letters. Everything up there is written in capital letters, ladies and gentlemen. That's the way I write, and that's the way I've done it ever since I was in high school and took a drafting class that taught us how to write in capital letters when you make a drawing of something. So that's the way I write to this day. So, ladies and gentlemen, what I'm telling you is that the only time I do not write all in caps is when I do chemical formulas, because some of our chemical formulas have 2 letters in them. And if you do that, some of our chemical symbols have 2 letters in them. And if you do that, the first letter needs to be capitalized and the second letter needs to be lowercase. So this is calcium, Ca. What is that?
Cobalt,
That is cobalt. It is an element on the periodic table. What is this?
carbon, and oxygen.
This that is carbon monoxide. That is a dangerous, poisonous gas, ladies and gentlemen, that can kill you because it comes off the exhaust of your car. 2 very, very different things. One is a gas, one is a metal. Okay? So we can't just take and capitalize things when we want to and make them lowercase when we want to. There's a rhyme and there's a reason for that. Okay, here's the other thing, ladies and gentlemen. When you look at the names on the periodic table, carbon, C, got it, understand the symbol. Oxygen, O, understand it, got it. Nitrogen, N, understand it, got it. Lead, PB, don't understand, don't got it. Why is lead PB? Why is tin SN? Why is gold AU?
They use the Roman version, the Latin version.
Latin, Roman, sometimes Greek versions of the words. For example, lead comes from a Latin word, plumbus, which means one who works with lead. That's where we get plumbers today, ladies and gentlemen, because all our pipes used to be made out of lead. So that's where the PB comes from for lead. Tin comes from a word stannous. That's why the symbol is SN. Gold, symbol,
Arm.
AU. You know why?
The Latin word is arm.
No. Because if someone steals your gold watch, you yell, AU, get back here! That's where the AU comes from. Actually, it comes from Aurora. Okay? So, ladies and gentlemen, don't always assume that because the word begins with a letter that that's going to be the symbol for it. Sometimes that is not the case. Okay? So there's the symbol, there's the name. Down at the bottom is this thing called average atomic mass, ladies and gentlemen. What that is that is the average of all sulfur atoms in the universe averaged out together to get their mass. Questions?
Is that ever updated?
What?
Is that ever updated?
They do update them occasionally, and you will see them also. Some are rounded more than others on some periodic tables. We'll talk about that later on. All right, good. So protons, how do we find them? What do they do? Here's what protons do, ladies and gentlemen. So copy that down, and then we'll talk about it. Because I don't believe I typed this in for you, did I?
No.
I really should be a nicer guy. I should type more stuff in for you. I'm sorry? Oh,
What do you do?
I don't know. Something. There, sorry about that. Sorry about that, ladies and gentlemen. Each part of the atom does something different for the atom, ladies and gentlemen. Protons are probably the most important. And the reason for that is they tell us what kind of atom we have. Protons and protons only determine what kind of atom we have. Two different atoms cannot have the same number of protons. Two different atoms can have the same number of electrons. Two different atoms can have the same number of neutrons, but two different atoms cannot have the same number of protons. So protons give an atom its identity. It tells us what kind of atom it is. It tells us that this is cobalt and this is calcium. Why? Because they have different amounts of protons in their nucleus. Okay? It gives the atom its identity. All atoms of the same type of atom have the same number of protons. If you went out into outer space, you found an atom with 6 protons in it, it's going to be carbon. I don't care where in the universe you find it. It's going to be carbon. And in a neutral atom, the number of protons is equal to the number of electrons, and that's how all atoms at least start out. They all begin neutral. Now, they do not have to stay that way, and most do not stay that way, but they have to at least start out that way. Questions? Okay. So the electrons are next, and here is what is their purpose. Well, protons give an atom its identity. Electrons are responsible for an atom's reactivity. What it will react with, if it will react with something, how it will react. Okay, that all comes from the electrons, ladies and gentlemen. And it comes from the electrons because they are the furthest away from the nucleus. Okay? In a neutral atom, the protons and the electrons are the same. All atoms start out this way. However, atoms can gain or lose electrons. And when you gain or lose electrons, you will become charged. Okay? In a charged atom, the number of protons minus the number of electrons will tell you what the charge is on an atom. But charges are normally something like +1, +2, +3, +4. Or -1, -2, -3, -4. That only happens because we gain or lose electrons, not protons. If we gained or lost protons, that would be a bad thing. Why?
Dumb. Would be dumb.
But why?
Wouldn't it become a different atom?
Because it would become a different atom completely, a different kind of substance. Okay? Different atoms can have the same number of electrons, ladies and gentlemen. Different atoms can have the same number of electrons. Now, I will put up the last slide here for today. Copy it down, and when you copy it down, then you could take your desk. You could prepare for the quiz by pulling out your periodic table, your solubility chart, and putting everything else away. But this is the last slide, and it is on neutrons. We will briefly talk about this on Monday, ladies and gentlemen, but you need your computers for the quiz. Sorry. Asia.
I can't access it because I can't close my Senso broadcast from last time.
Okay, then what you need to do is shut down your computer completely. That'll shut off that Senso broadcast, and then you can do the quiz. Okay? So I've had that happen to other students before too. But you have to shut down your computer completely all the way off.
Do you have other chargers? Because the one that I used was already at 0.
I will have to go see if there's any in the back. In the modules, ladies and gentlemen, as we just learned from Asia, the quiz is right here, but it is going to make you shut down all of your other windows before you start it, and that will be the only window that can be open while you are taking the quiz. The quiz is there. It is ready to begin. But unless you close all the other windows down on your computer, it will not let you open it to start it. So you need to close all of your other windows down except for this one that you are in Canvas in. Then when you click on it, it will open it. If all your other browsers are shut down, it will let you begin the quiz. When you are done, please make sure you hit finish and end and that you submit it, okay? And it will come to me. So I'll be back in a second after I see if there's a charger, and then I will be looking around to see if you have any questions. By the way, when you're taking the quiz, the first few questions where it asks you about graphing, all I want to know, does the line go up, down, horizontal, and is it straight or curved? That's what I want to know. So for the relationship, that's what I want to know. I'll be back in a minute. Sorry.
Thank you.
You're welcome. Shut your computer down. Start from again. Miss Brown. Can I, as soon as he's done with his quiz? Okay, not a problem. Thanks. Bye.
Close that out. Close it down first. And then see it. So reload into Canvas. Close your computer all the way down and try. Close it. Did that work? Did that work?
You do not need complete sentences when you answer the questions. You just need to completely answer it. So like again, as I said, if you can answer it by saying straight or curved, up or down, that's fine. Okay, now I'm gonna close this one here. Close that one there. Go back into classroom.
the shape for the poles, you have to do two, because you have to tell me the direction, up, down, horizontal, and it's straight.
Yeah.
Okay,